Student, in this video tutorial I am going to teach you about uniform and non-uniform motion. So you must have learned about uniform velocity and uniform speed. Okay, in uniform speed the body cover multiple distance which are having same dimension. That means their value are same. Okay, in same interval of time, whereas in uniform velocity the body attend or the body travel and cover equal displacement in equal interval of time. Okay, but this uniform motion is nothing but the uniform velocity. Okay, so uniform motion is same as the uniform velocity. The definition of uniform motion is the body is said to be in uniform motion if it travels in a straight line covering equal distances in equal interval of time. See the body cover equal distance in equal interval of time. But remember, the body is traveling in a line. That's why the equal distances are nothing but the equal displacement. Okay, so this is uniform motion. See in this diagram. The ball is traveling equal distances in equal interval of time. So we can say the ball is following uniform motion. Okay. Then example, if a car travel at a speed of 60 km per hour, then it will cover a distance of 1 km per minute. In this sense, the motion of the car acceleration is uniform. Okay, the car is traveling with a speed of 60 km per hour. That means it is covering 60 km per hour. Then if we will convert this hour to minutes, then we will get 1 km per minute. That is the velocity of the car. Okay, that is the uniform. That is, we can say the car is going in a uniform velocity. Okay, if the car is covering 1 km per minute, ultimately it will definitely cover 60 km per hour. एक घंटा में 60 किलोमीटर कवर डेफिनेटली करेगा because it is covering 1 kilometer in 1 minute time frame. Okay, then kinematics formula for uniform motion. Let's consider an object moving with uniform velocity v along the positive direction of x-axis. Suppose it occupies position x0, x and x dash at time t equal to 0, t and t dash respectively. See, this is the x0 is the initial point at time 0, this x that is after time t. Okay, then this x dash after time t dash. Okay, so then as the body is moving in uniform velocity, so we can say the displacement between this x0 and x is same, this x0 is same as this x dash, and a time frame between 0 to t is same as t and t dash. That means we can say x minus x0 is equal to x dash minus x. Okay, or t minus 0 equal to t dash minus t. Okay, so both the time frame are equal. Okay, then velocity of the object in the time interval 0 to t. We know velocity v equal to displacement with time. equal to final position minus initial position by time equal to x minus x0 by t minus 0, because there is final position is what in between 0, in between x0 to x, or in between the time prime 0 to t, the final position is x and the initial position is x0. So you can write x minus x0 t minus t0, then b equal to x minus x0 by t, or we can say bt equal to x minus x0 or x equal to x0 plus bt. This is equation 1, that is to get the position of the particles at time or instant t. Okay, then similarly we can find out the velocity of the object in the time interval t to t dash. See, in time interval the initial position is x and the final position is x dash, so we can write the velocity equation as displacement by time equal to final position minus initial position by time, then x dash minus x by t dash minus t, or we can write b equal to x dash minus x by t dash minus t, then b into t dash minus t equal to x dash minus x, then x dash equal to x plus b t dash minus t. Okay, so this is the equation for finding the position of the particle at time or interval t dash. From equation 1 we have got x equal to x0 minus x equal to x0 plus bt. So x minus x dash is the displacement in time interval t. Let's the displacement be s. Okay, so we can write s equal to bt. लिख सकते हैं कि नहीं? देखो x0 is going in left hand side direction, then we will get x minus x0. X minus x0 is s or displacement, so v equal to s by t. We can write s equal to vt. Okay, this equation can determine the distance traveled by an object in uniform motion. Okay, then these are some properties of uniform motion, and this is very important. Okay, you need to understand and you need to remember everything. This 1 2 3 4 5 6 point is very important. So the first point, velocity in uniform motion does not depend upon the choice of origin. Okay, it is not depending upon the choice of origin. अगर origin shift हो जा रहा है भी कुछ फर्क नहीं पड़ेगा, because displacement is does not depend upon shifting of origin, so velocity भी depend नहीं करेगा. Then the velocity of uniform motion does not depend upon the choice of time interval. Very true, it will not depend upon the choice of time interval. Okay, which be time interval हो, but the time interval need to be same everywhere. Okay, 5 second हो means 5 second is need to same everywhere. That means we can say in every segment, every equal segment of displacement, that 5 second time interval it need to be same. So we can say the body is covering what? Uniform motion. If the time is 8 second, okay, so that 8 second time interval is need to be same everywhere in every equal displacement segment. So we can say the body is going in a what? Uniform motion. So ultimately the uniform motion, the velocity of uniform motion does not depend upon the choice of time interval. Okay, for uniform motion along a straight line in the same direction, the magnitude of displacement is equal to the actual distance covered by the object. Straight line में जा रहा है means very true, that is the displacement, nothing but the displacement. The distance between the initial and final position, nothing but the displacement. It is following in a straight line. Okay, so the displacement will be equal to the actual distance covered by the object. Okay, then the velocity is positive if the object is moving towards the right of the origin, and negative if it is moving towards left of the origin, as we have discussed in displacement properties. Okay, then for an object in uniform motion, no force is required to maintain the motion. Okay, so there is no force is required to maintain the motion whenever the body is falling in uniform motion. Okay, in uniform motion, the instantaneous velocity is equal to the average velocity at all times, because velocity remains constant at each instant or at each point of time. So remember, whenever a body following uniform motion, the instantaneous velocity is equal to the average velocity of the body at every instant of time or at every point in that journey or in that path. Okay, so these are the properties whenever a body following uniform motion. Okay, then non-uniform motion. So non-uniform motion means just ulta of uniform motion. In uniform motion, see, the body cover equal distance segment in equal time interval whenever the body is going in a straight line. But if any changes occur in the body, that may be in the form of displacement, in the form of time, in the form of direction, that we can say the body is following non-uniform motion. Okay, so examples of non-uniform motion. See, for example, if we drop a ball from the roof of tall building, that means the ball will be follow what freely or fall freely from top to ground. We'll notice that in the first second the body will cover or the ball will cover 5 meter, and then in second it will cover 15 meter, and it will increase so on in next second and after next second. That means it is not covering equal distance in equal time interval. So the freely falling object is a example of what is an example of non-uniform motion. Then a boy kicking a football, it might cover 4 meters in first attempts, 6 meter in second chance, then 9 meter in the third attempts, and so on. So डायरेक्शन भी चेंज होता है, डायरेक्शन भी चेंज होगा. इट्स समवन किकिंग द बॉल, दैट देयर इज मे बी सम चांस ऑफ चेंजिंग ऑफ डायरेक्शन. एंड with direction we are seeing that the what the displacement or distance, the distance covered by the object is also changing, and here the object is ball. Okay, so this is non-uniform motion. And see, at every interval the boy is kicking the ball, so it is giving some force to the ball to move. So as we have discussed in the properties, whenever a body is following uniform motion, no force required to maintain that motion. So this is not uniform motion, or this is a non-uniform motion. So this is all about uniform motion and non-uniform motion. Okay, so oscillation of pendulum, non-uniform motion example. Okay, this is basic difference between uniform and non-uniform motion. Uniform motion means body moves along a straight line with uniform speed or steady speed is called uniform motion. Non-uniform motion, then the body moving along a straight line but with variable or change in speed. Okay, then in uniform motion body cover equal distance in equal time interval. Non-uniform में unequal distance in equal time interval. And uniform motion, the average speed is same as the actual speed of the object, but in non-uniform motion it is different from the actual speed of the object. Okay, these are the formula we will use to solve the problem, and the unit we will use with the distance and displacement follow the unit of length, that is kilometer and centimeter, and the speed and velocity will follow the unit kilometer per second, kilometer per hour, or meter per second. Okay, so thank you everyone.